and the snake hit me back in the eye.
This girl.
And that made me, it like scarred my eye, but somehow it's good now.
This girl that I danced with when she was younger, she dropped a knife and it cut her toe off.
Oh dear.
Oh no. Okay,
She
on
had to get it
Christmas
sewed
morning,
back on.
I got
It's
just
pocket
one
knife.
toe that's like really
Oh, God.
short. And so I was
Elbows.
playing with it.
Don't play with pocket
And
knives.
no, I was so dumb. I was playing with it and all of a sudden it cut my thumb. I still have the scar, it's right there. And it cut my thumb. It was like on Christmas Day. So I'm there sitting there looking at my thumb gushing out. And I'm like, well, that's great.
I mean, there
What
was
a great, what a
on Easter,
Yeah.
my
thing to
grandmother
have
decided
done
to
already.
change things up a little, and so all the kids were competing, and whoever won like the most eggs, then they'd be able to. Whoever got the most eggs would choose the first candy, and then whoever had the last eggs would get whatever's left over. I had the least amount of eggs, even though I had a freaking ton of eggs, and I was left with sugar babies. And I was eating them, and I bit down, and it ripped one of my molars out. And it
I always
wasn't
bite
even
the sides of
loose.
my mouth eating those, but I love them.
Oh,
But
That
I will
drives me
bite the
crazy.
fool out of the side of my
I
mouth.
had never had them before, so I bit down and it ripped a molar
I
out.
accidentally dropped one of my sweet tea. Anyway, I had some and they're like hard to chew. Like they don't get all stuck in my teeth.
Okay. All right. So we are going to pick up. We left off last week when we were online talking about our first bit of science, and we were talking about our research summaries. Okay. So thinking about our research summaries real quick. What was our big indicator when we're flipping through? And actually, let's go ahead, and if you have your test with you, I said research summaries. That's where we're starting today. Data representation. So look back if you have the one that we used the other day. Great, get it out. If you have the one that I just handed you, go ahead and take a look at it. Okay. So actually, I'll pull it up real quick. Nope, that's not what I need. I need the science test. Okay, so the one that I just gave you is going to be the one that we were working on the other day. And we said that the first one that we looked at was a data representation. What did we say are our key things that when I'm looking at a test and when I'm sitting down to take the ACT and I flip through and look at the different types of tests, how can I identify a data representation test immediately?
There's the graphs.
Graphs. Okay, I'm going to see graphs. That's going to be my big indicator. Now, one of the things that we're going to look at today is dealing with our research summaries that are going to be very similar to our data representation. Okay, so we're going to be looking at those in just a minute at what the main difference is. So let's take a look. That first one we had graphs. We knew it was data representation. We had just a little blurb at the beginning that gave us some information about what we're looking at, about what our graphs are about. And then we had the graphs, and then we had to interpret the data. Okay, let's look at the next test. Okay, so this is the one that I talked about was conflicting viewpoints. Today, we're also going to look at the first test in our red book at conflicting viewpoints, because this one is not the typical conflicting viewpoint test. But remember, we said this is where we're going to see, this one is, you know, the different viewpoints of students. Maybe it's going to be scientists that you're looking at, maybe whatever it is. But now let's go ahead and look at the third one. Notice here, I have labeled it as a research summary. We have graphs, we have all of that, but our big indicator here is where it says experiment 1 and experiment 2. Research summaries and data representation are going to be very similar, except that research summaries will either have experiment 1, experiment 2, study 1, study 2. It's going to be giving instead of having like figure 1, figure 2, it says experiment 1, experiment 2. Okay, so it's actually the results from an experiment or a study. So that's going to be the biggest difference in what we're looking at today with research summaries. Okay, so today we're going to look at research summaries and conflicting viewpoints. So we've talked about how there are 3 different types of passages. There are 6 passages total. 3 of them are going to be research summaries, what we're going to talk about today. 2 will be data representation, what we did last week, and then you'll have 1 conflicting viewpoints, okay? So by going into it, knowing what type of passage you have will help you to do better because you're gonna know how to kind of attack it better. All right, so today we're gonna start with research summaries. So I'll go back to what I just handed you. And actually you'll notice that we only have a front and back page and then a front of one as far as the information goes. All right, so I'm starting with the research summaries on the front, and it says research summaries require you to look at a scientific experiment and the data generated by the experiment. They are very similar to research summary passages, except that they will specifically state that they involve experiments or studies. Research summaries begin by giving a paragraph or paragraphs describing an experiment. The things that it's describing is going to be how it was designed, what's the background on the concept of the experiment or what the study is based on, what was the method by which it was carried out, and what is the purpose or other things about the experiment. So in the beginning, you should be able to kind of glean that information from the intro paragraph or paragraphs just to kind of get all that information. With that being said, you need to make sure, we're going to talk in just a little bit about what some strategies are as you're reading that information. What are you asking yourself as you're reading? Okay, I need to find out what was the method. I need to look at what was being affected during the experiment, that kind of stuff. The introductory paragraph or paragraphs will be followed by graphs or charts indicating the results of the experiment. So that's what those graphs and charts are telling me. Because of this experiment, this is what we found, okay? So it says approaching research summaries. You are not expected to be an expert on the information included in a research summary. So a lot of these things, most of these things, if not all of them, are going to be brand new information to you. They are not expecting that you have any prior knowledge. They are not expecting you to be an expert on whatever area that this research was done. What they are expecting you to do is to be able to analyze the information given to you and to be able to read the graphs and charts, okay? So you do not have to be an expert on the information. If you need to know something specific about a topic, the passage or the question will provide you with the information that you need to know. So if they say, you know, what is the blah, 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 they're going to tell you a definition of what that is so you know what you're talking about, okay? They're not going to expect you to have any prior knowledge except for how to find what you're looking for. Your task is to be able to look at the information given to you, identify the method and purpose of the experiment, as well as the data presented, and to understand the results that are shown. That is what you're looking for, okay? A concrete understanding of the scientific method and scientific experimentation is very helpful when answering research summaries, and we will be looking at those more closely a little bit later, okay? So probably, okay, so next week is Veterans Day, so we do not meet next week online. So that means week after next, we'll be back here, and that'll be where we start picking up with our third section in science, and we'll be looking more in depth at the scientific process and things like that. Tips for reading research summaries. Number 1, attempt to identify the driving question or hypothesis of the experiment. So that's the first thing that you're doing. Look at the driving question or the hypothesis. Are you reading and looking at the data result, or as you're reading and looking, say, what is the point of this? Why did they do this? That's going to be the first thing. As you're reading, why in the whole wide world did they even bother to do this? Specifically, ask yourself why the topic is being researched and look for the purpose or explanation as to why the experiment was done. This might be posed as a question the researcher is investigating, or presented in the form of a hypothesis, which is a proposed answer to a research question. Be sure to underline or circle this information so you can easily refer back to it later. Don't be afraid to write in your booklet. As I've said, with all of our sections, mark it up. Write in your booklet, help you understand the passage and the data better. And then also it helps you to refer back to it more easily. So the first thing we're going to do as we're reading, why in the world did they do this? What's the purpose? Second thing, determine how the experiment was conducted, specifically what was the method used to perform the research. Okay, so you're looking for the method, and it says a method is the physical process of how the scientists performed the experiment. It is the plan that was designed and written out before the research was started. It is usually clearly presented in a few sentences in the introductory information. So as you're reading, why did they do it? How did they do it? Okay, so we're doing why and how. Number 3 and number 4. Number 3 is to determine the independent variable. 4 is to determine the dependent variable. So we're going to talk about those two things. The independent variable is what is being changed. Okay, so think about this for a minute. Y'all have all done algebra 1. Think about when we were graphing, or even algebra 2. Think about when you have been graphing a line. Okay, remember we would set up the t-charts and we would have our x values. Those are our independent variables. And think about when we did our x values, what did we typically use? What 5 numbers did we usually represent as our x values when we're graphing? 0, 1, -1, 2, -2, right? Those are called independent variables. Those are the ones that we said, okay, if I use this, then what is y? Does that make sense? So we said, I'm going to change this. I'm going to change my number, and then I'm going to find a new answer. That's exactly what we're doing here with our experiments. We're saying, I'm going to change this. Maybe it's the light. Maybe it's the time. Maybe it's a location. Maybe it's a substance, whatever it is. Because I have changed this, what is the new outcome? So what I'm changing is the independent variable. The dependent variable is the outcome based on the change that I made. Okay, so independent and dependent. So we've already said we're looking at the why, we're looking at the how, now we're looking at what. What was changed and what was the effect? Okay, so why, how, what? What was changed and what was the result of that change? And then finally, number 5 says, look at the data presented and determine the results of the experiment and draw conclusions. So sometimes what may happen is with our data, they may show specific results, but then they also may say, based on the pattern that you see, based on how these are related, what can you conclude if something else happened? So you've got to be able to look at that relationship and data and make a prediction on what could happen if something was changed. Okay, so it's not going to be something specifically laid out in the data for you, but because you understand the pattern, you can make a prediction on what the effect would be. Okay, so that's what we're going to be looking at with number 5. So again, number 1 is why, number 2 is how, number 3 is what was changed, what was the effect, and number 5 is the results. Okay, so a quick summary. Research summaries are focused on experiments and studies that require you to look at the details of the experiment, the procedure by which it was conducted, and the results. And then you have to answer questions based on that. You're not expected to be an expert. You are expected to be able to read the information and draw conclusions. Research summaries usually begin by presenting a description of an experiment and then the results. Usually more than one experimental result or trial is presented in the passage, and the data is presented in the form of graphs or tables. So then we have just those steps that we just went through, those 5 steps. Okay, so those are research summaries. Remember, data representation just says, hey, we looked at these things and this is how we put it into a graph. We, whatever. Our research summaries, we're saying we've done an experiment or we've done a study. We have changed certain things during the course of the study or the experiment. These are the effects of those changes, and this is what the data is, so you make predictions. Now, on the last page, it is going to be our conflicting viewpoints passage. Conflicting viewpoints. There is always one conflicting viewpoints passage on the ACT science test. You'll be presented with 2 different views, commentaries, or opinions related to a scientific idea or experiment. You will need to identify the similarities and differences between the opinions. So as you're reading these, you're going, okay, how are they alike? How are they different? There may be nothing alike about them. It may be all differences. Okay, so that's what you're looking at. So to analyze a conflicting viewpoints passage, number 1, read the introductory passage carefully. The questions that go with these types of passages expect you to be familiar with specific details regarding the concept and opinions presented. Therefore, you need to carefully be able to read to pick out those details. Again, it may be that as you're reading and you see something important, underline it, circle it, mark it somehow so you can refer back to it. As with other science passages, that says passage, need to change that to passages. Don't get hung up on the content, okay? Don't get hung up on pronunciations. Don't get hung up on stuff you don't understand. If there's a concept that you're expected to understand, it's going to be explained in the reading, okay? They may give more of a definition in the reading, or they may give more information in the question. They may give further detail in the question that actually helps you to understand the meaning of a concept. Number 2, determine the scientific concept or idea that's being presented. So again, step 1, you're reading the 2 passages. Step 2, you're determining what is the concept that's being looked at here. Underline information that will enable you to refer back to, enable you to refer back easily if needed. Having a basic understanding of the concept being presented will help you better understand the different viewpoints that are presented. So it's the kind of thing where if you go, hey, I know that they're presenting different viewpoints and this guy thinks it says and this guy thinks it says, but I don't understand what it is they're talking about, then that's going to be much more difficult to deal with. Number 3, read each of the viewpoints in detail and identify the basic argument or theory presented from each viewpoint. Okay, by reading the details of this scientist, I can conclude that he thinks this is bad, good, whatever. After reading, make sure you can identify the major difference between the viewpoints that have been presented. Usually the major difference is easy to identify, but also pay attention to the details that make up that argument. Okay, so the details are going to be important here. The introductory sentence of each viewpoint will usually contain the overall argument of the viewpoint. Compare the initial sentences of each viewpoint and see what is different about them. It is good to underline the first sentence so you can go back and refer to it easily if needed when answering questions. And then number 4, determine the supporting evidence presented for each viewpoint. Circle or underline evidence that clearly supports the main argument as you're reading. Be sure to pay attention to specific details presented in the argument or statement. Now I have a note down here that no 2 passages are going to be the same. So there's really no way to look at and prepare for all types of conflicting viewpoints passages. But the main thing is analyzing them will be the same no matter how they are presented. Okay, so so being able to read it clearly, identify similarities and differences, know what it is that they're talking about, what they're giving opinions about, and know the details that make up each of the viewpoints. So now what we're going to do is we're going to spend the rest of our time really kind of digging into these types of passages. By doing these things, we're going to start with the research summaries first. We're going to look at research summary passages in those tests that I gave you, okay? So let's go ahead and change over to the test. Okay, so the test that I gave you, we've already looked at the first one. We did our data representation passage, and this was where we looked at the roaches, and we looked at the different types of foods that they were using to go into. We were looking to see what types of foods the roaches ate better, and then that way they could actually put those foods maybe in some type of pellet that would help to eliminate the roaches. Passage 2 in your packet is going to be what we're calling conflicting viewpoints, where it has the different students giving information. Like I said, this one we're going to go through it. It's not going to be, I'm going to want to go through our red book passage. Go ahead and turn over to the third passage, passage 3. Your paper will say it's page 44 at the bottom. So page 44 in your test little packet. Okay, so the first way that as I'm sitting down to take the ACT and I'm flipping through my little booklet and I go, hey, this is a research summary, why? Why can I identify it as a research summary? Okay, I can see where it's got experiments. Okay, it says experiment 1 and experiment 2, and I'm looking at my graphs. I can see immediately that it is dealing with experiments. It says in each trial, okay, so the terminology being used. That's how I know that this is a research summary instead of a data representation. So let's think back to the first thing that we said, tips for reading research summaries. The first one was we've got to look at the why, the how, and the what, okay? So let's go ahead and look at the information. When a solid metal, and notice that they're saying that it will be represented by the letter M. So wherever you see M, that means solid metal. So it may be the kind of thing where you underline solid metal right before the letter M. When a solid metal, such as iron, which is Fe, nickel, which is Ni, and zinc, which is Zn, is placed in an aqueous hydrochloric acid, or HCl solution, a reaction that produces H2 gas occurs. So now what they just told us is that when I have my metal, like iron, nickel, or zinc, what I've looked at here is I've said, hey, these are 3 types of solid metals. And it says that it is placed in aqueous hydrochloric acid. So I've got the metal plus the hydrochloric acid. A reaction is produced where I have those together plus H2, okay? Maybe I don't really know what H2 is, but I'm just kind of going with it, and I can see the relationship here between the wording and then the equation that they've given me. 2 experiments were conducted to study the production of H2 gas, or study the production of H2 in this reaction. What was the purpose of this study? To study the production in the reaction. Okay, so it told us in that first line the why. Why was this done? It was conducted to study the production of H2 in the reaction. So that's our why. So also, if you want to write out beside that why, and actually, here's my pen for my iPad. So 2 experiments were conducted to study the production of H2 in this reaction. So I can write the word why right by that. So I know why it was done. The apparatus shown in the diagram below was used to collect the H2 gas produced in each trial. So I can see here using this diagram, okay, where I've got the water in inverted graduated cylinder. Okay, what does the word inverted mean?
Yeah.
It's flipped over, right? So you can see the picture. And if you don't necessarily know what inverted is, if you know what a graduated cylinder looks like, if you've had chemistry, you know it's the tube and it has that little bottom so it can sit down. And so you can see where it's flipped over. So you can see where the tube is upside down and there is an outlet tube where it's running. So it's upside down in the fluid. You've got the tube and it's going into the container where that has, it shows that the tube is going through the stopper, that the top of it's called the flask. You can see your HCl solution. You can see your metal at the bottom. Okay, so being able just to quickly take a look at what the diagram is showing you and being able to understand what it is that's showing you. So it says the diagram. So it says as H2 was produced in the stoppered flask, it exited the flask through the outlet tube and displaced the water. Had been trapped in the inverted graduated cylinder. This displacement occurred because the H2 did not dissolve in the water. The volume of water displaced equaled the volume of gas, which is the H2 in the water vapor collected. So that's important there because it's telling us, it's describing this diagram is being further described here, okay? So what is this information called here? Look back at our first page of research summaries. What is this called?
How?
This is the how. This is the method. Okay, this is how it was done. Okay, it says that it shows us we've got the inverted cylinder, that it is dipped in and it's got the water. Then you've got the outlet tube. So as H2 was produced in the flask, it exited the flask through the outlet tube and displaced the water. So actually look at that. So so notice it says it exited the flask. So where did it start from? It starts at the flask and goes through the tube, and it actually displaces the water that is inside that inverted graduated cylinder. Okay, so when we look at this, we're so used to everything going left to right that when we read, when we do math, we start on the left and it moves to the right. So when we look at this picture, we're assuming that something is happening over here and it's going through this tube and going over here. All right, but if when you read this, it says it exits the flask, goes through the tube, and as it goes through here, it is displacing this water that is inside this graduated cylinder. Okay. So by looking at just those little details there, remember we said we've got to focus on those details. It exited the flask. So then that way, and even if that helped you to draw an arrow, you could even, like I said, mark up your diagrams. It's telling me that it's leaving the flask and displacing the water in the tube. And it says it exited the flask through the outlet tube and displaced the water that had been trapped in the inverted graduated cylinder. So basically that means that whatever it's pushing the water out. Okay, that's what it means by displacement, is it's pushing the water out of that inverted cylinder. And it says this displacement occurred because the H2 did not dissolve in the water. So because it had not been dissolved, it's displacing the water. Okay, so this is our how. Now it says in each of the trial experiments, steps 1 through 3 were performed. So this is telling me what is consistent through every single trial. Number 1, the apparatus was assembled and you had 25 milliliters of a 4 mole per liter HCl solution was poured into the empty flask. So every single one has the same amount. Number 2, a selected mass of either iron, nickel, or zinc was added to each flask, and the stopper was quickly inserted into the flask. So they're telling us that this is how they did it. This is all part of the how down here. They put the stuff in the flask. They put the metal in there and put the stopper in. When H2 production ceased, the volume of water that was displaced from the graduated cylinder was recorded. So they recorded the volume of water that was still left in that cylinder. The apparatus and its contents were kept at a selected temperature throughout steps 2 and 3. The atmospheric pressure was 758 millimeters Hg throughout all 3 steps. So we know that the pressure is exactly the same. But we know, and we know that it was kept at a selected temperature throughout steps 2 and 3. Okay. So let's go ahead and take a look at experiment 1. All right. So in each trial, a selected mass of Fe, Ni, or Zn. So again, if you don't remember that Fe is iron and Ni is nickel and Zn is zinc, it does not matter. What does matter is that you look at those and look at the key and use your key to look at the diagrams, to look at the data. So we can see that the black line with the black dots is going to be iron or Fe. So we can see we are comparing the volume of gas collected according to the y-axis. My x-axis is the mass in grams. So we're looking at volume compared to mass. So when I look at my iron, I can see that my volume was higher, and as my volume increases, my mass increases. So I see there's a direct relationship there. I can see I've actually got a direct relationship with all of them. As one increases, so does the other. And that's the same for all of them. Okay, so that's the main thing. Now, what did we notice about this in experiment 1? It says it was tested at 30 degrees. Okay. Now, let's look at experiment 2. First, let's look at our X and Y axes. Notice the first one was volume compared to mass. My next one, I'm looking at volume compared to temperature. Okay, so now I'm looking, my figures or my diagrams are different. I'm comparing two different things. Now, one thing to notice that is consistent on the graph is that my lines are going to be the same. So my key is going to be the same for each figure. But notice that it says in each trial, the metal was tested at a selected temperature. The first one was all done at 30 degrees. The next one, my temperatures change. So I can see that my volume increased as the temperature increased. Still, I have a direct variation. I have a direct result. As one increases, the other increases. But now, instead of volume and mass, I'm looking at volume and temperature. Okay. So that's what we're looking at here. Experiment 1, everything done at 30 degrees. Experiment 2, my temperatures change. Okay, so now let's go ahead and let's take a look at our questions. So you can flip back to, you can have your page handy. All right, so number 14 says, consider the volume of gas collected in the trial in experiment 2 for Ni at 30 degrees centigrade or Celsius. Now, notice here, it is telling me specifically to consider the volume of gas collected in experiment 2, nickel, at 30 degrees. Okay, so let's do that real quick. Experiment 2, nickel, 30 degrees. So that's going to be right here. Again, it's okay to circle it on your paper, right on your graphs. Okay, that's what they're telling you to focus on. Okay. So then it says the same approximate volume of gas was collected in the trial in experiment 1 for what mass of nickel? Okay, so the same approximate volume. So again, I'm having to look at experiment 1. Now I'm looking for the volume that is going to be about the same. So what would you say if we're looking at this point in this graph and I need to go this way and look at my volume? I can see that it's going to be somewhere between 120 and 130. All right, closer to 130. Now I've got to go back to my findings. And if I was looking between 120 and 130, that's going to be right here. Okay, and now I'm trying to find that same intersection. Let's see, it was for the same approximate gas was collected for what mass of nickel. Okay, so now I'm looking at nickel. I'm looking at somewhere between here. So I'm looking at this right here. Okay, so I had to start with this one first and look to see what is that volume. Then I had to go back to this graph, find my volume to find what is that point. Does that make sense? Okay, so now we look at so we can look at that and say, hey, it's 30. Now when I look at my answer choices, I don't even have to go through all of my answer choices. I've already read my graph, found my mass, therefore I can look and see that I've got answer H. Okay. So that one we said was answer H. Let's look at number 15. How many temperatures were tested in experiment 1 and how many temperatures were tested in experiment 2? How many do we know were tested in experiment 1? What did it tell us when we were reading the details about experiment 1? What did we find out the temperature was for every single one? 30 degrees. So we know that there was only one temperature in experiment 1. Therefore, I know I'm dealing with letters A and B. I can eliminate C and D. So I know that there was 1. Now I've got to look at how many temperatures did I deal with in figure 2, in experiment 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that right? Notice my y-axis gives me 9 different temperatures. How many were actually tested according to my data? According to my data, they tested it at 10, at 20, at 30, 40, and 50. Notice each one, they did 5. My goodness gracious alive. Thank goodness nobody was sitting there. Wait and see if they like send somebody to check on it. He's out there on the phone like nothing. All righty. So notice that even though my y-axis and my x-axis gives us 9 different temperature ranges, that is not how they were tested. My data points are telling me how many temperatures were tested. So we can see that what letter is going to be my answer. Look at that again. Experiment 1 had how many? We're on number 15.
D.
Is what?
B.
B.
Oh, wait, yeah, B.
Experiment 1 only had 1 temperature. That's why we know we're dealing with either A or B, because it only had 1 consistent temperature. Experiment 2, they looked at 5 different temperatures. So letter B tells me I had 1 temperature in 1, 5 temperatures in 2. Y'all good with that?
Yeah.
Okay, so again, that's just straight looking at the graph. Looking to see, okay, how many was in the first one? How many was in the second one? Let's move on to, so we said that one was letter B. Number 16, which of the following statements describes a difference? If you were taking the test, it would be a good thing to circle the word difference between experiments 1 and 2, okay? So what is the huge difference between 1 and 2? All right, so what we're going to do is let's look at the options here. Look at number F. Only FE was tested because it says in experiment 1. So it's saying, so part of the question says in experiment 1, F says only iron was tested, but in experiment 2, iron, nickel, and zinc were tested. Is that true or false? Why?
Because all 3 of them were tested.
They were all tested in each one. So I can go ahead and mark that one off and go, nope, that's not true. In experiment 1, iron, nickel, and zinc were tested, but in experiment 2, only iron was tested. False, because we know that they were all 3 tested in both. H, the same mass value for each metal was tested, but in experiment 2, multiple mass values were tested.
No, because there's not mass.
Experiment 2 has nothing about mass. You're exactly right. So we know that that is not right because we were looking at different masses for experiment 1. We're looking at different temperatures, for example, for experiment 2. So we're able to eliminate that. So now letter J says in experiment 1, multiple mass values for each value were tested, but in experiment 2, the same mass value was tested. So we found that in experiment 2, it was the same mass. What was different? Temperature. So in the first one, we had the same temperature, different mass. In the second one, we have the same mass, different temperature. Okay, so we found that that is letter J. Which of the following variables remained constant throughout both experiments? What did not change? The pressure, the mass, the temperature, or the volume? What did it tell me was consistent throughout? Because mass changes. Remember, we're looking at the change of mass. What did it tell me was consistent?
Atmospheric pressure.
The atmospheric pressure. Look at the bottom on the left-hand side.
Yeah.
The last sentence says the atmospheric pressure was the same through all 3. So I know, and if I didn't have that little detail, I know that my mass is changing. I know that the temperature changes. I know that the volume changes on all of them. So it's going to be the atmospheric pressure. All right, go ahead and take a break.
This election is really close.
Mm-hmm.
Yeah, like Biden really close to win. No, like,
Yeah,
like,
he is.
like
It
30.
hasn't changed since I last checked.
Yeah. Projecting for-
I don't know if the window.
I hope he doesn't.
That's one of the things where I was saying earlier that, it's the kind of thing where no matter who wins, somebody is going to be upset.
I think there's gonna be protests.
But the main thing that is consistent is that God's still in control and that no matter what, he is sovereign and he is good and he can make good of bad things no matter whatever it is. I mean, who realistically, when you look at both of them, I think there's bad things about both sides.
Yeah.
I think
My
there's
dad-
good things about both sides. So that's what the hard thing is just, whatever it ends up being, then it is what it is. And tomorrow we're going to wake up just like we did, it's all going to be, we just keep on moving, keep on going. That's one of the things that I don't understand about all the fear and the panic and the people on both sides. Oh my gosh, if he doesn't win, then it's going to be whatever. Well, no, guess what? It's going to be just fine. It's
Yeah,
okay.
they can't change
you know?
things that fast.
Exactly. I mean, it's going to be okay.
And if like Biden does something or Trump or Biden does something, there will be like he'll see either like the
Yeah, I mean, there's going to be consequences of whatever, and
and
it's
if like they try to do something, the
Mhm.
the U.S. people are just like, no,
Right.
we're not having that.
yeah. So it'll all be okay.
I forgot to turn the water off of the barn, and now the owner of the barn's mad at me.
Oh no!
Because they woke up this morning, they sent me a picture of the road flooded because I forgot to turn off the water.
Oh no!
I was like, I could have sworn I checked it. I'm so sorry. Oh. Now the whole like pasture's probably flooded.
Oh no! So it ran. When did you leave?
I left last night at 6:30
Oh yeah.
because I worked from 12 to 6.
Uh-huh.
And it was dark and I couldn't see and I freaking didn't know if I turned it off or
Oh
not.
goodness gracious!
I was like, what is this time change? I can't see it.
I seriously.
This room is getting so cold.
I know.
And I have to open the curtain, but I can't see anything.
It was
'cause
really
the
hot
blind's
just a
made with the
second
paper.
ago. I was like, what is this?
It may be try to open that other side.
That one.
Yeah. Oh no, I'm saying the
Oh,
other side of the curtain
oh.
instead of just gently see if that or
Well,
that may be
that's what I
worse. That might be worse.
I'll just open it.
There we go. Maybe just don't open it quite so far. Alrighty, so we looked at what was consistent for all of them, and it was that atmospheric pressure. Let's look at number 18. If a temperature of 5 degrees had been tested, okay, this is the one where they're asking you to make a prediction. Look at the correlation and everything, and they're asking you to predict if 5 degrees had been tested in experiment 2, would the volume of gas for zinc be greater than or less than 107 milliliters? So I'm going to look back at 5 degrees, where 5 degrees would correspond. Okay. So if I'm looking at where 5 degrees would be, obviously, I'm going to change my color real quick. Obviously, it's going to be like right here. Okay. Or maybe a little bit even further down. So let's say 5 would be about here. Again, if you needed to write it on your thing, you could. Notice the trend here. Okay. So we're looking at, they told us to focus on zinc. Okay. So zinc is going to be my lowest line. So notice if my trend kept on going, it's kind of going in this passage, right? Okay. So if this is 110 right here, and this would be 105 right here, okay? And they're asking right here, if this is where 105 would intersect, is it going to be greater than 107 or less than 107? Because look right here real quick.
It's gonna be less.
What number do you think they're saying this is right here?
7.
Probably 107. So we see it's going to be 107 at 10, right? Therefore, we can assume that if it goes to 5, it is going to be less than 107. Okay, so we know less than 107. Let's look at our answer choices. Number 18. Notice the first one says greater than, second one says greater than. I can go ahead and eliminate both of those. Now I know I need to focus on H and J. And it says less than because for a given metal, the volume of collected gas decreases as the temperature decreased, or the volume of gas collected decreases as the temperature increased. So we're looking at, did it decrease as the temperature decreases, or does it decrease as the temperature increases? So it's going to be H. It's decreasing as the temperature decreases. Okay, so looking at those relationships. As my temperature goes down, my volume goes down. Consider the balanced chemical equation in the passage. Based on the equation, if 10 moles of HCl are consumed, how many moles of H2 are produced? Okay, so let's take a look at that. When I'm looking at my balanced equation, okay. One second. Consider the balanced chemical equation in the passage. If 10 moles of HCl are consumed, how many moles of H2 are produced? So what I'm looking at here is the point where it talked about moles. Symbol. 4 moles. Why am I having trouble with this? This is where okay. So bless you.
Let's see.
Okay, so basically what I'm doing is notice my 2 in front of the HCl, okay? Notice that 2 would be distributed to the H, so that's what I've gone ahead and done here. And notice that when it reacts, you've got the M goes with the Cl2, and the H is by itself, okay? So when I'm looking at my equation, if I've got 2 of the HCl to begin with, okay? And I changed it to 10. So basically I'm looking at when I had 2, how do I explain this? This is where my lack of chemistry comes in. So basically in this situation, it's a 2-to-1 ratio, okay? So if it's a 2-to-1 ratio in the example they've given us, and we're changing the next one to 10, what is going to be my ratio now? If it was 2-to-1 to beginning, we're going to be 10-to-5, okay? Because remember, we've got to have it's got to be a proportion here. And when we have proportions, that means 2 equivalent ratios or 2 equal fractions, or whatever you want to call it, ratios, fractions. You could put those as fractions either way. But so basically, if we started in the original equation, we had 2. Now it's saying, what if we had 10? Well, if I multiplied that by 5, then I have to multiply the other by 5 as well. So I end up with number 19 would be 5. Does that make sense? Okay. Now in number 20, it says, suppose that the trial in experiment 1 with 0.25 grams of zinc is repeated. So I know I'm focusing experiment 1, 0.25 zinc. Okay. So I'm going to run back real quick. Example 1, 0.25 zinc is my triangle. So I'm right there. Okay. So it says, what if that was repeated, except the inverted graduated cylinder is replaced by inverted test tubes, each completely filled with 60 milliliters of water. Based on figure 1, how many test tubes will be needed to collect all the gas? Okay, so how many milliliters did we say that it was in the beginning? What was the consistent information? Wasn't there something?
25.
That was how much? Selected mass. Why was I thinking that we saw something that said a consistent, but I may be confusing that. The apparatus was assembled 25 milliliters. It was the 25 mils of solution. Why did I think there was something about 30? Suppose the trial in experiment 1 with 0.25 grams of zinc is repeated, except the inverted graduated cylinder is replaced by inverted test tubes, each completely filled with 60 mils of water. So basically, I'm looking at 25. I know I'm going to be here between 90 and 100. did I think that somewhere there was something about 30 milliliters? Oh, I think I'm thinking about the 30 grams in experiment 2. That's where I'm getting that 30. Okay. That's why I kept thinking, I know I've seen something about 30, but that's an experiment 2. It's saying 30 grams was tested. All right. So, how many test tubes would be needed to collect all the gas? Oh, duh. Oh my goodness gracious. What is the volume of gas collected here in this experiment as it is? I made this one way too hard. Okay, look
Wait,
at, so notice, okay, look at what it's asking. So it says, if we look at the volume of gas collected, that is up our y-axis, right? What is my point of intersection for 0.25 grams? Where's the arrow where I drew? It's between what two numbers?
90 and 110.
It's between 90 and 100. Okay, if each test tube could hold 60, how many do I need to hold between 90 and 100? 2 of them, because how many could 2 hold?
120.
120. One can hold 60, one can hold 120. I mean, 2 could hold 120, so I know it's going to be 2. I was trying to make that so much harder than it needed to be. Basically, all I had to do was, what is the volume at 0.25? Well, hey, it's between 90 and 100. Let's say 95. So if it needs to collect 95 milliliters of gas and a test tube collects 60, then I know that I need 2 test tubes to collect all the gas. Okay, like I said, I was trying to make that so much harder than it really was. Don't overthink it. That's what I was doing. Okay, so that was our example of a research summary. We had to really, and obviously you don't have that much time when you're taking the test to break down one thing, but I wanted to take the time to break it down step by step. So now as you practice with these and as you're going through, you can kind of think about, okay, what was the process that we went through with that? Now I've got to do it a whole lot quicker. Okay. And again, so now what we want to do is let's go ahead and look at our conflicting viewpoints real quick. So go back to, it's going to be passage 2. So go back a passage. Also go ahead and turn in your red book to passage 3 in the test 1 in your red book. Just, I want you to be able to see another example of what a conflicting viewpoints would look like, another type. So in my book, it's around page 84, but it's going to be passage 3 and the science test in your red book, the first science test. So it's going to be the third passage of your science. It talks about star formation.
Is this passage 3 or passage 2?
Passage 3.
Okay.
Does it say star formation begins with the gravitational collapse?
Yes.
Okay. So in the red book, you can see here that this conflicting viewpoints, notice we have scientist 1, scientist 2, and scientist 3. We have 3 different scientists here that are talking about their, so you can see the beginning of the passage says star formation begins with the gravitational collapse of matter in an interstellar gas cloud. A protostar forming, and it says in parentheses. So go ahead and make sure you're looking at that in your red book. Did y'all, for a while was I thinking that our test one was the same? Is it not?
I forgot my book. We're in a
Okay, that's
different book.
Okay. So the main thing is though, that also it gives us some basic information first, and then it breaks it into scientist 1, scientist 2, scientist 3. Okay. So in this one, notice that we've got the basic information in the beginning, and I'm going to erase all this in red just so I can. Okay. So notice here, we've broken it up into student 1, student 2, student 3, and student 4. So it says a teacher provided the table below to the students in a science class. The table gives 5 properties of each of samples A through H. So again, 5 properties of each. And that's going to be mass, volume, density, melting point, and boiling point. Okay. The students were told to assume that each sample is a completely solid cube composed of a single hypothetical pure substance. So I know that A through H, these are my different substances. Then I have their mass in grams, their volume, density, melting point, and boiling point. And it says, note, assume that the mass, volume, and density were determined at 20 degrees Celsius, and that all 5 properties were determined at 1 atmosphere of pressure. So those would be things to identify. The temperature stayed the same, the pressure stayed the same. So those are consistent. The teacher asked each of the 4 students to explain how these data could be used to predict which samples are composed of the same substance. Okay, so asking, how can you tell what would be at the same substance? Student 1 says, if 2 samples have the same values for all 5 properties, they are composed of the same substance. If 2 samples have different values for any of the 5 properties, they are different substances. So student 1 says, if they're all 5 exactly the same, they're the same. If they have anything different, they're different. Student 2 says, if 2 samples have the same values for any 3 or more of the 5 properties, they are composed of the same substance. Okay, so basically what I'm going to do, and just kind of reading these 2 things, for student 1, I'm going to put 5, all 5, same. Student 2 says if 3 of 5, so 3 of 5, same. If 2 samples have the same values for fewer than 3, they are composed of different. Actually, let me change this up. So all 5 the same as the first one. So on this one, I think what I'm going to do is greater than or equal to 3, same. Less than 3, different. Now the next one says if student 3 says if 2 samples have the same, they are the same substance. So 2 equals same. If 2 samples have different values for any of these 3, they are composed of different substances. So these 3, so it says melting point, boiling point. If 2 samples have different values for any of these 3 properties, they are composed of different substances. Melting point nor boiling point by itself can distinguish between the substances. So basically, it's saying that it would be the other 3 other than melting point or boiling point. Student 4 says if the 2 samples have the same density, melting point, and boiling point, they're the same substances. If 2 samples have different values for any of these 3. So basically what we're looking at is how they are each defining them. The first one says they all 5 have to be the same. Student 2 says they have to have 3 or more being the same. Student 1 says that 2 can be the same, but student 3 says they have to have 3 the same, and it has to be density, melting point, and boiling point. So let's look at number 7. Based on student 1's explanation, this is where I know I need to focus on student 1. The same substance compares both of the samples in which of the following pairs? Okay, so it says samples A and B. Are A and B all the same? The mass is the same, the volume is the same, the density is the same. Are the melting points the same?
No.
Are the boiling points the same? Nope. So I know that I can mark off A. Student 1, they all have to be the same. What about B and C? If I look at B and C, I can look immediately and see that the mass is different, so I can mark that one off. C and D, I look at C and D. I've got 6, 6, 3, 3, 2, 2, 237, 237, 88, 85, 885. Those are exactly the same, so we know that those would make student 1 happy. And then if you wanted to check, you could look at D and E, and immediately you could see right off the bat that D and E are different, so it could not be that. Okay, so answer number 7 is C. Number 8, based on student 3's explanation. Okay, let's go to student 3 and understand that student 3 says, if two samples have the same mass, volume, and density, so mass, volume, and density have to be the same. Okay, so look back. Student 3's explanation, the same substance composed of the samples in which of the same following? So I'm looking at mass, volume, and density for A and C. So I know I'm looking at the first 3, mass, volume, and density. And we said we're looking at, what did I say? A and C. Okay, I can look immediately for A and C, and I see that the mass is different, so I mark off letter F. Next is B and E. Okay, I look at B. I know those are different. I look at B and E. I've got 8, 8, 4, and 2. I know those do not work. So I mark off letter G. Letter H, F, and G. Look again. I'm looking at F and G. 8 and 4. Nope, those are not the same. So I mark them off. So obviously I don't even have to look because by process of elimination, it's going to be J. If you wanted to check, you're looking at G and H. So you're looking at these 2 right here. I've got 4, I've got 1, I've got 4. Of those 3, they're the same. Number 9, suppose that the temperature of sample A is increased to 250 degrees at 1 atom of pressure, or 1 ATM, whatever it is, at 250. Would sample A be a solid or a liquid? So I'm looking at sample A, and I'm increasing the temperature. So looking at sample A, and so it says if it's increased to 250 degrees, would it be a solid or a liquid? What is the melting point of sample A?
126.
126. So notice that with A, B, C, and D, A and B both say solids. C and D say liquids. So we know it would be a liquid because it would melt at 126 degrees. So if it's at 250 degrees, it's going to be melted. Okay, so it's going to be a liquid. So for number 9, we know that letter C is going to be the answer because it says liquid because the melting point is 126. All I had to do was identify that corresponding information. I saw that the melting point was 126. I know that they're asking me, what if I increase the temperature to 250? Number 10, consider the claim that 2 samples have the same density, will be composed of the same substance, regardless of the values of the other 4 properties. Which of the students, if any, would be likely to agree with this? Okay, so how many points of likeness are they saying that we're supposing? Consider the claim that 2 samples having the same density. So we're talking about one characteristic in common, right? Do any of the students say that if one thing is in common, they're going to be the same?
No.
No. Student 1 says all 5. Student 2 says it has to be 3 or more. Student 2 says that they have to have the same mass, volume, and density. But then student 4 says they have to have the same density, melting points, and boiling points. So we know that they're all saying there has to be at least 3. So what would your answer be on this one? None of the above. None of them say it could just be one characteristic. Number 11, which of students 2, 3, and 4 would be likely to agree that sample A and B are composed of the same substance? Okay, so let's look at A and B. How many of the characteristics of A and B are alike? Everything but melting and boiling point. Okay, so based on melting and boiling point, that means that there's 3 things in common, right? So I know that students 2, 3, and 4 all say that 3 things in common. Student 2 says 3 things and it doesn't matter what they are. So I know student 2 is going to be one of them. Which one says that mass, volume, and density need to be the same? Student 3 or student 4 say that the mass, volume, and density need to be the same.
Was it 3?
Student 3, yeah. See, it says if 2 samples have the same mass, volume, and density. Okay, so we know that it's going to be students 2 and 3. So I can look at it. So it says 2 and 3 only, 2 and 4 only, 3 and 4, or 2, 3, and 4. We know it's going to be letter A, that it's only students 2 and 3. Number 12 says, consider the statement, 2 samples have the same mass, volume, density, and boiling point are composed the same substance, even if the 2 samples have different melting points. Which of students 2 and 4, if either, would be likely to agree with this statement? So how many things are they saying had to be the same in this? Mass, volume, density, and boiling point. So how many of those items are we saying would be alike?
4.
There's 4, right? Consider the statement. Okay, so it's saying that 4 are the same. Would there be student 2 or student 4 would agree with that? Or is it neither? What did student 2 say? Look at student 2. But look at student 2. It says if 2 samples have the same values for any 3 or more of the 5. So it could be 3, it could be 4, it could be 5. Okay, how many did we say are alike in this example? 4 of them. So student 2 said 3, 4, or 5. So it would be student 2. Students 3 and 4 said 3 only. Student 2 said potentially 4 or 5. Number 13, suppose that the temperature of sample D is increased to 890 degrees. Okay, so we're looking at sample D, 890 degrees. Will the sample's density be lower than or higher than it is at 20? Okay, so let's look at sample D, 890 degrees. Sample D, 890 degrees. Will the sample's density be lower or higher than it was at 20 degrees? And so our options are lower because D will be a gas, and gases have lower densities than solids. B says lower because D will be a liquid, and liquids have lower densities than solids. C says higher, that it will be a gas, and gases have a higher density than solids. Or D, liquid, because liquids have higher densities than solids. What happens when something boils? It becomes a gas. So we know that something dealing with being a gas And so now what we have to understand, this is going to be a prior knowledge piece of information. And so there will be certain things that we talk about, what prior knowledge stuff we need to have. What about density of a solid versus a liquid versus a gas? Which one has a lower density? Gas. So I know gas has lower density. Which of these answer choices would give that information? Gas and lower density. Letter A. Okay. So realistically, everything that we were able to answer was based on what we had here, but we did have to pull in that little bit of prior knowledge about solids, liquids, and gases. Okay. So like I said, as we continue going through the science portions, we're going to be looking at, we'll talk about science vocabulary that you need to know. Like I said, we're going to study more about the scientific method that will kind of help you with these things. But kind of the thing today that I wanted to really do was take some time to go through these different types of passages like we did last week when we had our data representation, to be able to say, this is how we're breaking it down, and to see that every single answer that we needed was right there in those graphs and charts and the information. There was nothing really, except for the knowledge of solids, liquids, and gases, that we had to pull from prior knowledge. Same thing with the last one that we did with our research summary. Everything that we noted or that we needed, we were able to go directly to the information they gave us. Okay. So now it's just you getting comfortable with, okay, when it's a research summary, I'm looking at wow, why and how. I'm looking at why it's being done, how it's being done. I'm looking at what are the changes that are being made from experiment to experiment, and what are the similarities, what's the same, and being able to take that. Conflicting viewpoints. I'm looking at the same set of data, possibly, but I'm looking at how is it interpreted differently by different people. So I'm having to look at what does the data consist of, and how is it being evaluated by different people. Okay, so those are going to be the main things about these passages. What questions do y'all have? Any questions? All righty. So what I would like you to do, in the science, did I have y'all do any of these passages last week?
I think
Passage 4. Let's get passage 4 real quick. If you didn't bring your other one with you, let's go ahead and look at the answers for passage 4 so you can go back and compare yours. Okay, so you can check your answers. So your first bit of homework will be to check your answers for passage 4. So check answers, passage 4. Yeah, I have homework, passage 4. So that was last week. Was what's the date today? Today is 11/4. So last week was 10, 31, 30, 29, 28. 10/28 was homework. So this is 11/4. Check your answer. So let's look at passage 4. Number 21. Go ahead and circle these on the one I just gave you if you don't have the one that you did. If you do have, and I think we've still got like 15 minutes left. So in passage 4, if you have your one that you actually answered, great. If you don't, just answer it on the one I just gave you. Number 21 is C. So check your answers if you have it, write the correct one beside it, and if not, go back and check. So 21 is C, 22 is H, 23 is C, 24 is H, 25 is D, 26 is J. Okay, so what I want you to do is part of your homework. I want you to look back at what your answer was. Look at what the correct answer was. If you got it right, fantastic. If you missed it, I want you to try to figure out why you missed it. Evaluate why did you choose the answer that you chose, and can you see why the answer is what it is? Okay, so I want you to assess that. And then your other homework is going to be passage 5. I want you to do passage 5. Okay, passage 5 is a research summary. So you can see it talks about the study. Hold on one second, let me make sure that's the one I want you to do. All right, we've got a research summary. Huh?
Passage 5 is a research summary.
Yeah, I was trying to decide. I think 5 and 6 both are. Let's go ahead and do 5 and 6, passage 5 and passage 6. They are both research summaries, but they're very different in the way they, you know, the way that they are presented. So go ahead and do passage 5 and 6. So check your passage 4, look at what you missed, if you missed anything, why you missed it, and then passages 5 and 6. Go ahead and answer those and we will check those. Okay? Awesome. Questions? All righty. So what we'll be doing next week is we will continue going through our science. Like I said, we'll be looking at scientific method. We'll be looking at science vocabulary that's going to be necessary. I think what we're actually starting with next week is going to be the types of questions that are being asked. One of the things that by looking at what type of questions being asked, it helps you to know, do I just need to go directly to the chart? Do I need to make an inference? You know, am I comparing, contrasting, whatever, things like that. Okay. So how did y'all feel going through these two today? Going through the questions, could you see how you would go directly to the charts and graphs and the information to find them?
Yeah.
Okay. So does that make it a little more comfortable or still a bit intimidating?
It makes
Okay, good. So just really recognizing that it's not a whole lot of, you don't, even if you don't know what the passage is talking about, you can still kind of figure it out. Same thing with me and like the chemistry thing. I was getting so hung up on that, but then just realizing, same thing with trying to, you know, look at where that graph intersection was, and I'm getting hung up on, oh my gosh, they, you know, they said that they've increased this. Well, that doesn't really matter. I'm just looking straight at the graph to answer it. Okay. So it's not impossible, I guess, is the main thing that I want you to see. The other thing also to talk about is, I was going to look real quick at, where is my scaled score for that test one? So again, the other thing that I want you to also think about is, as far as your thinking about where you want to be, there are 40 questions on the science test, okay? Missing half of them. If you missed half of them, you would score about an 18 or 19. Think about if you missed, so that would be missing 20 of them. If you missed 10 questions, if you answered 30 of them correctly, you're at a 26. Okay, so that's a pretty big jump going from missing 20 to 10. So halfway in the middle, if you miss 15 of them, you're at about a 24. So you can even see, hey, I can still miss 15 of these questions and still be in a pretty good score range. So it's the kind of thing where, you know, if you get to something just like that one that was hanging me up, if you get to something that you find that's taking too much time, yes, and move on, because you can afford to miss some of these, okay? Unless you're looking for a perfect 36, you know, you can afford to miss some of them, and it's okay. You don't have to have that pressure of, oh my gosh, I've got to get every single one of them right on every single passage, okay? And you may find that conflicting viewpoints. You may find that that's easier for you to answer or more difficult. And so again, based on, is the data rep, the research, or the conflicting viewpoints, which one is easier or more difficult for you to do, then you can say, hey, I know these are the passages I like. I can really focus in and do really well on these, and I don't have to be as stressed about the ones that I struggle with. Okay. All righty. So homework, check your answers for passage 4. Look at why you missed, what you missed, and how could you have figured out the correct answer. And then passages 5 and 6, go ahead. I'm sorry. Yes, 5 and 6. I think I wrote 4 and 5. 5 and 6, do those 2 research summaries. And that will be it. All right, so it's 11:57. It's a little bit early, but you guys can go ahead and go. Okay. So I will not see you guys next week. I hope y'all enjoy your Wednesday off for Veterans Day, and then we will join back here in 2 weeks. Okay.
Thank you.
So next
right.
week we're not meeting in class?
Huh?
So next week we're not meeting.
Next week we are off
Oh, yeah,
on
that's
Wednesday
virtual.
because of Veterans Day.
I guess we're not gonna have a class.
No, we will not have class next Wednesday. We are off.
My stuff won't fit in my backpack.
I was gonna say, and then that's the hard part.